Hello, ladies and gentlemen. I would like to welcome you here today. We would like to present a three-dimensional geometry affecting the melting of ice กาญจนาพิเศษกวิทยาลัยสุราษฎร์ธานี School Thailand ID code MMM04 with the following members.
My name is Yanisa Bunsi.
My name is Nacha Chaudhary-Bun.
My name is Thanyavarat Sukasim.
My name is Namtip Kamluan and
My name is Hadarat Pomchuai. I'm going to start with statement of the problem. Ice nowadays is considered a popular thing and effect. A hero in daily life, better put it in a drink to keep the drinks cool and refreshing in hot weather. It can be considered to be a great helper even to keep food fresh by freezing. Therefore, the ice is in great demand as a result. Various stores produce a large amount of the ice and sell it in response to the needs of consumers. The shape of the ice is different. There are large tubes, small tubes, cut ice, and ice cubes, which affect individual melting time. If you can find a way to store the ice for a long time by studying the factor affecting the store melting of ice, it will help reduce the cost of operator of the ice is an important factor. If we know which three-dimensional geometry affects the slow melting of the ice, it will have a positive effect on entrepreneurs. Therefore, the researchers were interested in studying the three-dimensional geometry of the ice that affect the melting of ice. The three-dimensional geometry to be studied were a circular shape, cylinder, cone with pyramid, square base, and rectangular prisms.
Then the objectives of this study is to study the three-dimensional geometry of ice affecting its melting. Variables independent three-dimensional geometry dependent the melting of ice. Moderator variable volume of water, the freezing time and the temperature of ice making.
The experimental equipment that show you is siren, mixing bowl, glass, plastic tray, beaker, digital timer, and the last one, geometric model.
Continue experimental procedures. First, choosing a three-dimensional geometric shape consisting of sphere, a cone, a cylinder, a pyramid, and prism for use in our experiment. Second, measure water 80 centimeters cubic. Put in all 5 types of 3D geometric shapes. Third, place it in a tray and put it in the freezer by store in 2 degrees Celsius temperature for 8 hours. Fourth, remove the ice from the freezer, then put in container or surface area in room temperature. Fifth, record time at 30 minutes Then measure the volume of melting liquid water and record experimental results. 6. Repeat this experiment for 5 times. Record the result by cut of maximum and minimum melting volume of water time out. Then find out standard deviation and average.
Experimental results. The table shows the volume of dissolved water form of 5 geometric shapes at 30 minutes, followed by this table. This one is the bar chart shows the average volume of water at mature by melting each geometric ice shapes at 30 minutes, followed by this bar chart.
Let's go to the next point, the discussion of results. The researcher will study the three-dimensional geometry of the ice that affect the melting of ice. By means of the three-dimensional geometry, their study will are circular shape, cylinder, cone, square pyramid, and rectangular prism. To study the production of the ice in variant shape, study the melting of ice at 30 minutes. Measure the volume of melted water from the ice. The results show that the volume of water from melting ice followed by a circular shape, water volume at 41.80 cm cubic, rectangular prism 45.20 cm cubic, cylinder 46.00 cm cubic, cone 47.80 cm cubic, and square pyramid with water volume 49.80 cm cubic. Sequentially, please, the solution volume was observed. A circular shape and rectangular prism will dissolve accordingly. The ice should produce in a circular shape to keep the eye melt as low as possible or apply the knowledge from this study case to produce other products that require cooling as well. Beneficial other broad entrepreneur and consumer. The last one is suggestion. First, choose to demonstrate with beverage to compare the solution by using real life. Second, transfer control variable. The volume, height, later experiment. Third, choose to demonstrate and compare the type of socket ice and without socket as market price. Thank you all for listening.